Here are questions 7.3, numbers 7, 25, and 27. 25 and 27 are actually very long. I will not give you those two problems in their entirety on the exam, but 7.3, number 7 might be. So here we go. 7.3, number 7, integral from 0 to a of dx over a squared plus x squared to the 3/2 power. So let x be a tan theta, dx is a secant squared theta d theta. It's a definite integral, so x equals 0. Put a 0 here, that means tangent of theta is 0, which means theta is 0. X equals a, if you put an a here, a equals a tangent of theta, that means tangent of theta is 1, which means theta is pi over 4. So my new integral is from 0 to pi over 4. Dx is a secant squared theta d theta. The denominator is a squared plus x squared, a squared plus a squared tangent squared theta to the 3/2 power. Factor out the a squared. If a squared 1 plus tangent squared, 1 plus tangent squared is secant squared. And the square root of that is a secant theta. If you raise it to the 3rd power, you have a cubed secant cube theta. Okay, take out the a over a cubed, this is 1 over a squared. You have secant squared divided by secant cubed, which is 1 over secant theta. Reciprocal of the secant is cosine of theta. So I just simply integrate cosine of theta, which is sine theta, 1 over a squared, sine theta from 0 to pi over 4. Plug in pi over 4, you get radical 2 over 2. Plug in 0, you get 0. So radical 2 over 2a squared. 25, I will not have you do that problem in its entirety on the test, but maybe at least a setup. What you have to do is complete the square. So first factor out the negative. So negative parentheses x squared minus 2x, leave the 3 alone. Complete the square, half of negative 2 is negative 1, square root is 1. So negative x squared minus 2x plus 1 plus 3 plus 1. Rewrite it as 4 minus parentheses x minus 1 squared. Then substitute t equals x minus 1, which means x equals t plus 1, dt equals dx. So x squared is now t plus 1 squared, and that's what helps make the problem really long. Radical 4 minus t squared. So let t be 2 sine theta, dt is 2 cosine theta d theta. So this comes out to be 2 sine theta plus 1 squared. Radical 4 minus 4 sine squared theta times dt, which is 2 cosine theta d theta. This factors in the 4 times 1 minus sine squared, which is now going to make this 4 sine squared theta plus 4 sine theta plus 1. That's this thing squared. That's really long. Radical 4 cosine squared theta under the square root, 2 cosine theta d theta. That's going to make this 2 cosine theta. So 2 cosine theta times another 2 cosine theta is 4 cosine squared theta. So I have 4 times the integral of distributing. So I took out that 4. So 4 sine squared theta cosine squared theta, that's I1. And then 4 sine theta cosine squared theta, that's I2. And then 4, which comes outside, cosine squared theta, I3. And I'll just say, etc. This, you have to do the identity for 1 minus cosine 2 theta over 2, 1 plus cosine 2 theta over 2. This one's nice because you have an odd exponent, 1, and an even. And this is harder because you have an even exponent. So it can be done. It's going to be real long. I will, again, not ask you this whole thing on the test for a 1-hour test. It's going to be too long. Of course, for 27, it's too long. So I won't have you do the entire thing, but maybe just a setup. So first you add 1 and quickly subtract 1. So x plus 1 squared minus 1. Let t be x plus 1, dt equals dx. So radical t squared minus 1 dt. Then let t be secant theta, dt is secant theta, tangent theta, d theta. So I is square root of secant squared minus 1, dt, which is secant theta, tangent theta, d theta. This comes out to be tangent squared, whose square root is tangent. So you end up with integral of secant times tangent squared theta d theta. Change tangent squared to secant squared minus 1. So integral of secant cubed minus secant. Okay, so call it I1 and I2. I2 is easy. That's ln absolute secant theta plus tangent theta plus C2. I1 to integrate secant cubed. Okay. Let u be secant theta, dv is secant squared theta d theta, integrate by parts. Du is secant theta, tangent theta, d theta. V equals tangent theta. I messed up here, so forget that. So I1 is uv, secant theta, tangent theta, minus integral of v du, secant theta, tangent squared theta, d theta. And then what you do is change that to secant squared minus 1. And so if you break that up, you have secant theta tangent theta minus integral of secant cube minus secant theta d theta. And you integrate secant cube again, that's the same as your original I1. So this is plus secant theta, that's an ln secant theta plus tangent theta plus C2. This is secant theta tangent theta. This is a minus I1. So you have blah, blah, blah with I1 equals all this stuff that has an I1. You put the I1s together, you have 2 I1, and you would divide by 2. So you see how long it is. So you will not have to do this entire problem on the test. All right, so that was 7. You might have to do this problem in its entirety, but not 25 nor 27 on the test for Friday.